Hi everyone, my name is Herdeline Ardoña. I'm an assistant professor here at the UCI Chemical and Biomolecular Engineering, and I'm here to talk to you about our soft matter thrust. So if you are a student who wants to do graduate research on this area, definitely our department has a lot to offer. We have research groups that work on looking at the fundamental structure, function, processing correlations for soft materials, but we also have groups that work on developing new materials towards specific applications. So starting with the lab of Professor Ali Maraz, the Colloid Science Laboratory, they focus on the physics and principles of self-assembly for soft materials. And the two images here represent the main materials that they are looking at, which are solid state emulsions and also bigels, which stand for bicontinuous interfacially jammed emulsion gels. And for these bigel systems, they are interested in exploring its applications for healthcare, such as cell delivery or tissue engineering, as well as for electrochemical energy storage applications. So in our department, we also have Professor Albert Yee's group, the Laboratory of Bio-Inspired Nanotechnology. And this group specializes in surfaces and mechanical properties of polymers. And they are exploring the applications of nanostructured surfaces currently for materials that have antimicrobial properties, as well as targeted applications for biomedical devices. So the one application that is being highlighted here is its application to create contact lenses that have a nano texture that can prevent infections for these types of materials. We also have the lab of Professor Alon Gorodetsky, the Biomolecular Electronics Lab, and they are currently pursuing this very interesting direction, cephalopod-inspired technology that allows them to pursue that allows them to potentially apply this in the future for infrared camouflage technology. So the idea is to recreate the protein nanostructures called reflectin in cephalopod cells, as shown here, and they are trying to engineer the human cells with these types of nanostructures so that you can tune the light scattering properties of these cells, rendering them transparency. We also have the group of Professor Suwen Wang, who is interested in nanostructured biomaterials. And so their group span, the efforts in their group span from fabricating these biomimetic materials all the way to nanostructure and physical-chemical properties characterization, looking at the architecture, all the way to the drug release from these types of materials. And this helps them tune their materials for specific biological applications or looking at biological responses. Applications such as cancer immunotherapy, looking at controlled drug delivery, tissue engineering, and vaccines. Finally, my group focuses on the development of biomimetic and adaptive materials, and we're interested in adding optical and electronic functionalities to these materials so that we can make them compatible and useful for excitable cells, such as cardiomyocytes. And the application that we are looking at for these materials is so that we can use them to control cellular behavior. So for example, optically controlling excitable cells such as cardiomyocytes, or developing platform technologies, hydrogel bioscaffolds that have chromatic and responsive properties, and also developing molecular biosensors that can be used for drug or toxicant screening. So that's just a glimpse of the different research activities going on for the soft matter thrust. Definitely, if you have more interest, please take a look at the websites of these individual groups and the individual PIs. And with that, thank you very much. I do hope that you consider applying to our department.